Hello there. As we see with polynomials, they have the form an times x to the n plus an minus 1 times x to the n minus 1, and so on until a naught, which is the constant. An is called the lead coefficient, and n, the power, the highest power on the variable, is the degree of the polynomial. Let's look at a few examples. So f of x equals x squared plus 3x minus 1. Its degree is the highest power on the variable, which is 2. And for g of x equal 9x cubed plus 1, what is its degree? Well, the highest power on x is 3. The degree of a polynomial is very important because the degree allows us to determine how many zeros the polynomial has. So, the degree of a polynomial determines how many zeros we have, and more specifically, a polynomial of degree n has at most n zeros. Now, as we'll see, some of these zeros, the zeros are what make the function equal to 0. Some of these zeros are real, and some of them may be imaginary. But at most, we're going to find n zeros. And in addition, a polynomial of degree n has at most n minus 1 turning points. So what does this mean? Well, let's take a few examples. So here we have a graph of two quadratic polynomials. Quadratic polynomials have degree 2. That means the highest power on the variable is 2. So x squared. And here we have a quadratic polynomial, and we notice that it has two x-intercepts. And those x-intercepts can be thought of as zeros. They are what make the polynomial 0. So it has two zeros, and according to our theorem, it's going to have at most two zeros. Here's another quadratic polynomial. It's opening down, and we can see that this polynomial has no real zeros. So in this case, it has two zeros, but they're not real. Up here we have two real zeros, and here we have two what we call imaginary zeros. And we'll see how to find these zeros as we go along. And also notice that we have degree 2, that means it has one turning point, at most one turning point. And each of these quadratic polynomials just has one turning point. The turning point is right where it changes direction, here and here. These functions are given as x squared minus 6x plus 2 and minus x squared plus 2x minus 6. So these are quadratic degree 2 polynomials. Let's look at some examples of cubic and quartic polynomials. So here we have a cubic polynomial that's degree 3, the highest power is 3, so we have an x cubed in this polynomial. And notice it has 1, 2, 3. 1, 2, 3 x-intercepts. And those are three real zeros. So 3 zeros, at most it's supposed to have 3. And actually it has two turning points. 1, 2, at most. You could have cubic polynomials with less than that, but in this case it's two turning points. Goes up, goes down. You could have a cubic polynomial with no turning points as well, and they do exist as well. In this case we have 2. Let's go to the quartic degree 4 polynomial, and just go back to the cubic. This lead coefficient was negative because it starts high and comes low. In this case, cubic an was less than 0. In the quartic, an is greater than 0. The lead coefficient is positive because it starts high and ends high. And how many zeros do we have? 1, 2, 3. Now we're supposed to have at most 4. So this doesn't contradict the rule we just talked about. We have 3 zeros, one here, one real one here, and this one, you might think there's an imaginary one existing, but this one is just touching the x-axis, and we're going to talk about what that's called. That's called a multiplicity on this 0. So this 0 actually occurs twice when it just touches that x-axis. And this is degree 4. And notice we have how many turning points? 1, 2, 3 turning points. So what does this mean, this idea of multiplicity. So the idea of multiplicity is that the same zero can occur several times. So we have two types of multiplicity, odd and even. Let's start with even. Look at the graph we had looked at just now, the quartic polynomial. The graph just touches the x-axis here and bounces back up. So we would say this zero has even multiplicity. It could be multiplicity 2 because it occurs twice. It could be 4 if it occurs 4 times. In this case, because this is a quartic polynomial, degree 4, then because we have 2 real zeros here, this must have multiplicity 2 to make the maximum of 4 zeros. So, in other words, let's recap. If R is a 0 with even multiplicity, the graph touches the x-axis and turns around. Now what about odd multiplicity? So if R is a 0 with odd multiplicity, then instead of bouncing back up at R like even multiplicity, the graph crosses the x-axis at R. Here's an example of a cubic polynomial with degree 3, and it has odd multiplicity. In other words, it seems to be crossing the x-axis at one point, that is right here at the origin. So we would say that 0, at x equals 0, occurs 3 times. So it has multiplicity 3. So we'd say x equals 0 is a 0, and it has multiplicity 3. So it's just 1 0, but it's occurring 3 times. And in fact, this looks like the graph of y equals x cubed. And if you think of a y equals x cubed, has 3 zeros, x equals 0, x equals 0, and x equals 0. Now how do you find zeros of polynomials? Well, it involves some theorems, and it also involves a quadratic formula. So let's look at that.